Okay, question number 4. So now we have a series circuit, but we've switched out one of the 40-watt light bulbs with a 75. And again, I put quotes around all these because we don't really know what the power is. It's no longer in parallel, so we can't assume that it's really giving off the power that it's sold as. All right, so question 4A is, what is the voltage across a complete circuit? It is still 120 because we still plug it into an outlet in the United States of America. All right, question B. It says, what is the resistance of each bulb? Well, the resistance stays with the light bulbs. So our 275s were 192 ohms, 192 ohms, and our 40 watt is 360 ohms. And those are still true. Those really are the numbers. All right, so what is the resistance of the complete circuit? We can just add them up. Total resistance will be 192 plus 192 plus 360, and that gives us 744. All right, what is the current across a complete circuit? All right, to figure out the complete circuit, that is I total current. And if we use Ohm's law, this works for total resistance or total current, total circuit, or just a resistor. We're doing total. So total voltage is going to be equal to total current times total resistance. Or we could do V divided by I. Oops, I said the wrong one. Not V divided by I. We're going to do V divided by R is equal to our I, which would be our total voltage, 120, divided by 744 ohms, and we get a total current of 0.161 amps. Okay, what is the current across the... So it's asking for the current across everywhere. Well, if we know that it leaves the battery with 0.161 everywhere on this circuit, will have the same, same current, 0.161, 0.161, 0.161, everywhere across here. Okay, so the total current stays the same throughout because it doesn't get split anywhere. All right, so that's going to be for the both resistors. That's E and F. What is voltage across one of the 75-watt light bulbs? Well, to figure out the voltage across here, we're going to use Ohm's law just for the resistor. So V equals IR, which equals 0.161 times 192, and that gets me a voltage of 30.97 volts. Same with this one, 30.97, because it has the same current and the same resistance. It's going to have the same voltage. Okay, across a 40, you're going to do the current of 0.161 times the resistance 360. And that's going to get you a voltage of 57.96 volts. All right, now the deal is, just so you know, these three should end up adding up to the total. Now there might be some rounding or something, but basically all three of these should add up to our total voltage of 120. Okay, the actual power being used by one of the 75-watt light bulbs, well, power equals current times voltage, and so we would be using 0.161 times our voltage of 30.97 to get you your power, which is 4.99 watts. Okay, so that's for each of these 75s is going to be that. The power across the 40 watt will be, again, current is 0.161 times the voltage of 57.96, which is basically 58, and you're going to get 9.33 watts. So what's the actual power? Oh, you could add them all up, 4.99 plus 4.99 plus 9.33, or you can still do power equals current times voltage, and the power is going to be equal to the current of 0.161 times the voltage, which is 120. Both will get you the same answer. Okay, that's it. Thanks for watching.